Okay, what we're doing here is we are looking at solving simultaneous equations, and we're doing that by either adding or subtracting our two equations. So there are some steps to take with these. It's really important you follow these steps. Basically, it's when you come to do these, let's just go through. So to solve these, first thing we do, we label them 1, 2. Doesn't matter what we call them. We can call them Fred and Stacy. Doesn't matter. We're just calling them 1 and 2. What I'm doing, I like to put it in circles so that you know I'm giving them a name. And then what we're going to do, we're going to look to see whether we add or we subtract. What we're looking for is coefficients of our numbers, so coefficients of our polynomials. So here 2 is a coefficient, -2. Here we'll put that in. We've got 1, and then the last one we've got is 3. So that's what we're trying to do. Now what we're doing is we're looking for coefficients of the same magnitude. So if we look at this, it's the same number, different sign, doesn't matter about the sign, we're looking for the same number. Over here, 1 and 3 are different, so that's not what we're interested in. Here, 2 and 2 are the same. So now because we've got a -2, what we're going to do is we're going to add the two equations. So what we're going to do, we're going to say equation 1 plus equation 2. Alright, so if we're going to say, so the measure is doing 2x plus -2x, we end up with 0x. And then we've got -y plus, so -1y plus 3y, we've got 2y. And that's going to equal 3 plus 9, which is 12. So just to go through that again, 2 plus -2 gives us 0. So we've got 0x plus, and we're going to say -y plus 3y gives us 2y, and that equals 12. Okay, because 3 plus 9 equals 12. So now from there we've got 2y equals 12, 2 times number equals 12. What is that number? That number has got to be 6. And what we do is we label that as equation number 3. And then what we say, we're going to say sub 3 into, and we're going to substitute into one of these two to make it easier to work with, and I'm going to put it into equation number 1 because I don't have to do any multiplication here. So now I've got, so I'm saying 2x minus 1y, which is now 6, equals 3. So 2x minus 6 equals 3. And now we just solve it like normal. So -6, we're going to add 6 to both sides. So we're left with 2x equals 9. And then we'll say x equals 9 over 2. So for this, y equals 6. X equals 9 over 2. And to check on what we would do is we would substitute our values in there. Okay, if we want, we can check that fairly quickly. Make sure that's an equals. We substitute 9 into 2 here. 2 times 9 over 2, let's use the highlighter. 2 times 9 over 2 gives us 9. Minus 6 gives us 3. It works. Okay, over here, what we're doing the same kind of thing. We're looking for the magnitude of coefficients. So 3 and 6, different. 2 and 2 are the same. Now, because they're both positive, we subtract. So once again, we label our equations, 1 and 2. What we're going to do, we'll say, now I'm going to do equation number 2 minus equation 1, because then we'll have 30 minus 12. We'll get a positive. So 2 minus 1. So 2x minus 2x gives us 0x. Plus 6y minus 3y gives us 3y. And that equals 30 minus 12, which is 18. So 3 times some number equals 18. We imply that number's got to be 6 again. What a fluke. Okay, now that we've got that, we label this equation 3, and let's substitute. So we'll sub 3 into, I'm going to choose one of those two. Let's see, y equals 6. I'm going to substitute into the first one. Into 1, because I'm multiplying 6 by 3, whereas over here I'm multiplying 6 by 6. Just easy to work with. So we're saying 2x plus 3 times 6 equals 12. So 2x plus 18 equals 12. And we've got to bring this 18, we've got to remove this 18, so subtract 18 from both sides, and we'll have 2x equals -6. So then x equals, so 2 times the negative is negative 6. That number has got to be negative 3. So what we're looking for with this is using elimination. What we're doing is we're looking for the magnitude of coefficients. Whatever the magnitude is, then we will either add or subtract our whole equations. If our magnitudes are different, then we add. If our magnitudes are the same, then we subtract. If they had to both be negatives, we would still be subtracting because they're the same. And then we just go through how we solve. The idea of elimination is that we have a zero coefficient. That's what we want to do. So by this, if we add, we'll end up with a zero coefficient. Here, if we subtract, we get a zero coefficient as well. But that's the story. And then once you've got that, you solve, substitute, and solve again. But that's the way we solve simultaneous equations using elimination.